video is going to show you how to use the binomial theorem to expand binomial to an exponent, like to the sixth or fifth, fourth, whatever. And it's kind of assuming that you already know Pascal's triangle. So Pascal's triangle's up here. You don't know what that is. You have some other investigation to go through in a different video. But if you're comfortable with the idea that that's Pascal's triangle, you can start looking at what's going to happen here. So what I want to do, I'm going to rewrite this a little bit as in some different colors. So I'm going to put A plus, we'll go with B in green, and I'm going to put this all to the sixth power. And I'm going to use this to match up with this. So you can see in Pascal's triangle right along this angle, I've got 1, 2, 3, 4, 5, 6, and I would keep on going on forever. So whatever my exponent is here, that's what tells me which line I'm going to use of Pascal's triangle to get my coefficients. So the first thing I'm going to do is just list out those coefficients and just have them spaced a bit. So I'm going to have 1, and then I'll have a 6, 15, 20, 15, 6, and 1. And then I'm going to go back, and now I'm going to look at these values, and I'm going to match it with this exponent. So I'm going to start right here with a to the sixth power. And then I'm just going to decrease by 1 with each term. So I would have fifth, fourth, this one's going to be cubed, squared. This one's to the first power. And we don't write it to the first power, but we can know that it's there. As a matter of fact, I could even write one more. This is going to be a to the 0 power. But we don't write things like that. So that a to the 0 power, anything to the 0 power is 1. So I would go ahead and just take that one off of there. And then same thing with the 1 on top of the a. We just don't write that. And so we leave it like this. But you can see it does go all the way 6, 5, 4, 3, 2, 1, 0. With the small exceptions at the end where we just write things differently. So now I'm going to move on to my B term. Now I'm going to do the same thing, but just in reverse. So I'm going to start over here. This is where my B to the sixth would go. And then I've got to the fifth power here. This one's to the fourth. Cubed, squared. To the first power again that we don't write, and then this one over here, it would be a to the 0, but since that's 1, we don't write it at all, right? So I'm just going to leave that one out. And now you can see this expansion. So this is your answer. And this is what you would get if you filled out a plus b times a plus b times a plus b times a plus b until you did it 6 times. This is your result. And so it's a huge shortcut. If you imagine the amount of time and paper it would take to FOIL that out so many times that we can just jump right in here to the answer. Now, a couple of things that you can notice when you take a look at this. One thing that stands out right away is that if you take any individual term, like say we look at this one right here, notice that the exponents add up to 6, which is, again, this number that kind of governed this whole thing was to the 6th power, and that it happens everywhere. 2 plus 4, right here there's an unwritten 1, right? And this one we had a to the 0 that we didn't talk about, 6 plus 0 would be 6 also. So you can see that on every single term, those exponents are going to add up to be whatever our first exponent is that we're starting with. Other things I can notice is that if this is the first term, this is the second term, this is the third term, fourth, fifth, sixth, and seventh, that in every case, whatever number I have right here, this exponent is 1 less, right? So 1 less than 5 is 4, 1 less than 4 is 3, 1 less than 3 is 2. And so we can use that pattern to make this process even more efficient, as we get better and better about it by just observing these patterns, right? And so we don't have to think through every single term as we create it. One other piece that's interesting is there's a continuity calculator, which we'll go over more, but just for now, if you understand that you could go into math, as you press the math button on your calculator, then you're going to move your cursor over until it has this PRB highlighted right here. And then if you go down to the third choice, you've got this NCR button. And you'll find that if you type in, if you type in these values, if I put 4C0 in there, I would get 1. If I put 4C1, I'll get 4. And 4C2 gives me 6, 4, and 1. So this actually generates a line of Pascal's triangle. I don't think I have on here on this slide, but this is, let me go back a couple. This is one of the lines, this line of Pascal's triangle right here, right? It's the one that's 1, 4, 6, 4, 1. Well, if I look at, what was just generated by these NCR buttons on the calculator, it gave me a line of Pascal's triangle. So now I could kind of go one step further, and I could say that, if I were expanding a plus b to the fourth power, that I could just say it's 4C0 a to the fourth. And then 4C1, a would come down by 1, and now b would show up. And then plus 4C2, and now I've got a squared b squared. And what I'm doing with each one of these is I know that the exponent of a is going to drop, right, with each term. But I also know that when I add these together, it always has to give me 4 back again. That 2 plus 2 is 4. That 4 plus the 0 that would be on the b is 4. It's always coming back to this, right, to get this value. And this leads us to kind of the last little piece of this, is that we can find any term we want of binomial expansion. So in this case, it's saying find the 16th term of this 3a plus b to the 25th power. Super complicated. Even with the binomial expansion, I wouldn't want to run this thing out to the 25th place because it would just take forever. But I'm only looking for one of the terms, not the entire expansion. And so I can start piecing together little pieces of my pattern and come up with a shortcut way to do this. One is that I always notice that whatever this number is here, that's what I start with in my NCR. Another observation we can make if we go back and look at, that's on video. If I go back and look at this expansion here, is that I used, for my first term, I used a 0 right here. For the second term, I used a 1. For the third term, I used a 2. So I'm always using 1 less than whatever the term is. So back to my problem here, it says that I'm looking for the 16th term, right? Well, we said we always use 1 less than whatever term it is. And so that's what we're talking about in this space. And this R value is just going to be whatever this is, whatever term they're asking for, subtract 1. That's the number that goes here. Now, I can also observe that this number and this number always match, because we found out that same observation about this number over here, right? We said it's 1 less than the term. On the 5th term, this value was 4. On the 6th term, this value was 5. So these are, they're matching. This one and this one, they're both following the same rule right here. So whatever this number is on this spot, I just match it. I put it over here again. And then, of course, the last little piece of the puzzle is that we notice that this exponent plus this exponent, they always have to add up to be this number, right? That's up here. It always comes back to that exponent. So I'm going to get all this off here because I'm drawing all over this place. But if you pause this, take a picture of this, whatever you're going to do, this will guide you. This piece right here will guide you through any problem where you need to find any term of the expansion. So if I went ahead and did this, if I plugged all these pieces in, what I would put in my calculator is I would have 25C15, right? So I go to the calculator and plug that in. And then my A value in this case is actually 3A. So I'd have 3A in this spot. And then the B value is just a B. So I'm going to have B in this spot. I know that whatever exponent is here is also here. So that's going to be a 15. Plus I know that this one plus this one have to add up to be 25, which means that this needs to be 10. And so I've got 25C15 times 3A to the 10th power times B to the 15th power. Now you can put that on your calculator and get the numbers if you want on your own. I'm not going to waste your time with that now. But that's the idea of how you can shortcut this here.